It's not supposed to be the hard part. This is systems of three equations. And I've got the steps laid out here, and I guess I can read to you in case you can't read. But we're going to have three variable equations. You're going to have x, y, and z, or a, b, and c, or just any three letters in the alphabet, okay? FUC might be appropriate because that's what you probably think about this. All right. No big is that okay?
I got it. I got it.
We're going to rewrite a system of three variables into a system of two variables by picking a variable and eliminating it from two different sets of equations twice. That's step one. That's the big step. Then we're going to do yesterday's lesson. We'll have a system of two equations, and we'll either do the elimination method or substitution method, which are now extra ways there. And then we're going to plug all the way back in. Work our way all the way back to the top. We plug it in. It's actually called the double elimination method. And kids complain about this every year, but I swear to you, I remember doing this in Algebra 1. And we didn't have three variables. We had like A, B, C, D, E. We had 5 variables. It took a long time. One problem was an entire front back sheet of paper. And we did this stuff way back when without calculators. You can do it now. So we're going to start this one. You need to pick a variable to eliminate. You got x, y, z. Why'd you choose y?
It has the smallest numbers.
Smaller numbers. Always smaller numbers. Now, what you have to do is you have to eliminate y from two different sets twice. You can do this any way you want. I'm going to pick on these two equations. I'm going to eliminate y.
How do you do it twice?
You'll see.
Just.
I'm going to pick on those two equations, and I want to eliminate y. All right?
Yes, that's the smallest number would be 6.
Smallest number is 6. We want to turn that 2 into a 6. We want to turn that negative 3 into a 6. So what do we multiply the top equation by? 3. How about the bottom equation, or the second equation? 2. This guy gets 3. This guy gets 2. And you got to give that to everything, not just one thing. It's to all of it. It's the distributive problem. No doubt about it. That becomes 12x plus 6y plus 9z is 3. Then you got to 2 everything on the second one. If you don't understand y, maybe you'll see why in a second. 4x minus 6y plus 10z is a negative 28. Now, the mistakes kids make here is they just forget to do one thing. You forget one thing to 2 or 3, and it's all ruined from then on out. You got to do every step 100% right. So it does have some tedious in it. It's not that it's hard, it's that it's tedious. It requires a high level of accuracy. So, check yourself, kids. I'm not going to spend time checking myself, but check yourself. Now, if we add these two equations together, what's going? Y's, right? 16x plus 19z is a negative 25. That's an equation that looks like what we've been working with, right? Two variables. That's the goal. Get to what we've been working with. Now, I just worked with equations 1 and 2 to write that equation. I need to pick on a different set of equations and do the same technique. Instead of doing 1 and 2, I could do 1 and 3. Looking at the original equations given. Instead of doing 1 and 2, could I do 2 and 3? So I need to do a different pairing and do the same technique.
Well, I do 1 and 3.
Want to do 1 and 3?
Yeah.
So the pairing here has been chosen by Sam. I think by Sam. It's 1 and 3.
Oh, yeah, you're not. You shouldn't do that.
Hold on. I can't hear time. You good? You asking why I picked 1 and 3? You pick any different pairing.
Yeah, he's supposed to change one.
Well, your numbers are 2 and negative 1, aren't they? Multiply the bottom equation by 1. Top equation can be left as is. It's the bottom one that's got to be doubled. Because we want these two to cancel. I am gonna rewrite the top equation, because you need to. I don't think you can hold it in your head. I wouldn't dare do it. And that was the bottom one. Twice 6x is 12x. Twice the negative 2y. Twice the negative y is a negative 2y. Twice the 4z is an 8z. And twice the negative 1 is a negative 2. Your choices here are add or subtract, kids. Add. You add these together. Now, if you can figure out how to do this stuff, you're probably in the top 75% of all students. I've done this for years. Most kids cannot do this. Add 1 and negative 2, you get a negative 1. Now, you now have two equations that only have x's and z's. This is yesterday's stuff. It is. Did Mr. Garner take you all through threes? Systems of threes? No? It used to be a state one out for once. Because I'm going to take these two, I'm going to line them up. Yeah, we'll wait till we line up first. I was hoping I could just pick on part of it. This worked out really easy. Add or subtract. Subtract. Why? What disappears? These problems are chosen to be kind of on the easy side. 16 minus 16 is 9. What's 19 minus 11?
8.
8. How about a negative 25 minus a negative 1? Negative 20. That gives us a z value of? Okay. Now let the rest of y'all catch up for a second. I hope you're listening to me. Don't be sitting there on autopilot, just copying the board, copying the board, copying the board. Learning is an active thing. And yes, it sucks. It's hard. It's boring. This is math. But it's active. Everybody of you's got to be here. Your hands, your eyes, your ears, and yes, your brain. What the kids do. Now we have z. Can I plug that in somewhere and get x? Yeah. You can throw it, you can take that z, and you can throw it in either there, or you can throw that sucker in there. Can't you?
Could you plug it into the original?
The problem with the original is that those still have three variables. If you plug in the original, you won't be able to figure anything out. You gotta go back up one step.
The ones you're pointing at also has 3 variables.
Oh, yeah, well, that's me. That was not where I meant to draw those.
Yeah, I think the ones that start with 16.
I can throw it in here,
Oh, okay.
or I can throw it in there.
Oh,
That's what I meant to draw.
I did the problem.
Bottom one's fine. That was 16x plus 11, negative 3's equals negative 1. That's a negative 33, and change that to addition, you go say negative 1 plus 33, and you're going to get. Okay, I'll write this all out. What are you going to add? Well, 33 minus 1 is 16x is 32. X is 2.
Still got a phone. Wow.
Yeah, I'm going to shrink this up real quick. Make sure everybody's got everything in their copy.
Since we have both variables, we'll be able to plug in the original.
Now we go after originals. Oh, God, it's too long. Oh.
Oh, we got time to all of the.
Well, in 2020, I'd call you something else, but now everybody gets offended. You know what I call you. It's 2020. Yeah, that's my mouth.
All right.
You have X and Z. Ecstasy. There's a place for X. There's a place for Z. Who cares? Well, that makes some sense. Will you get the same answer that I'm going to get?
Probably.
One would hope.
Unless I did something completely wrong.
Just plug them into one of the originals. The originals have 3 variables. I have one that you needed yet. So 4 2s makes an 8, 3 negative 3s makes a negative 9, 8 negative 9 makes a negative 1. 2y minus a 1 is a 1. You add 1. 2y is a 2, and y is 1. Now, when you did systems yesterday, I hope you did this on your homework. It should have stated this, it didn't. Everything I did, I wrote everything as an order pair.
Yeah, that's right.
That's what you're supposed to do.
It's what you wanted.
That's what I wanted. That's why I did the notes that way.
That's what you said yesterday.
I don't get how we got what y equals.
I plugged those guys in there, Grant.
Right, and I've got 12x minus y minus 12z equals negative 1.
How do you have 12x?
Oh, Z. You would get rid of the X and Z.
I think he plugged.
Aren't you replacing x with 2? Did you use the bottom equation?
I use the bottom equation.
Okay, so what's 6 times 2?
6 times 2 is 12.
Why do you have an x?
So the x goes away. Oh, okay.
Because you're plugging.
That's what confused me is I wrote it down with the x's.
No, you're replacing x with what?
Right. Yeah, that's what I did wrong.
You're still going to get 1. Anyways, we're going to do an ordered triplet. Instead of ordered pair, it's called a triplet.
Go ahead and do it. Correct.
And it goes x, comma, y, comma, z. Why would it go any other way? It'd be alphabetical order, kids. Alphabetical order. X, Y, Z. So this guy had an x value of 2. It had a y value of 1. And a z value of negative 3.
So basically, we just use alphabetical order.
Yes. Everything in math is alphabetical order. I swear it is. Everything in math is in design, so it's in alphabetical order. That's it. Now, it takes a long time for me to teach just one problem, and the truth is, that's probably about how long it would take you to do each individual problem. In the beginning, ideally after you do a couple of these, you get a lot quicker. Well, that's the idea. See if we can get at least one more of these suckers knocked out. Let me, I don't want to talk about some of this today. I'll come back to it tomorrow. Tomorrow I'll talk about classification and a system with no solutions and infinite. I don't want to throw you off too much. Let's talk about word problems. Which one do we want to do? We'll do this one. You and your friends buy healthy snacks because that's what you'll do for a field trip. You spend a total of $8, Jeff spends $9, and Curtis spends $9 as well. The table shows the amounts of mixed nuts, granola, and dried fruit. Doesn't it sound like some good snacks that each person purchased? What is the price per pound of each type of snack? Well, you're talking about 3 people. That means you can write how many equations? You can write 3. So that's what we'll do. We'll write 3 equations. This is the easy part, believe it or not. I'm going to write an equation for you. What do you want to call mixed nuts? You want to call it M or N? You bought 1 pound, right? So 1X or 1M. Granola. About a half pound. Now, if I was up on the board, I'd write 1/2. 0.5 G. Dried fruit. What do you want to call it?
call it, yeah, we'll call it F. It's fruit, plus 1 fruit. Whatever those costs per pound, when you add them all together, you get the money you spent. You spent $8. Well, eating healthy is actually very expensive. That's why most people are pretty fat. How about Jeff? Oh, sorry, Ty, you had a question. You just put them in line them up. Same variables, obviously. We chose M for mixed nuts, G for granola, F for fruit. You know, don't rewrite the wheel here. Talk about Jeff and his equation. How many M's? 2 of them. How much G? 0.5 G. How much F? 0.5 F. What'd he spend? 9. All right, we're on to Curtis. 1 M. 2 G. 0.5 F equals 9. That's the easy part. You better make sure you understand the easy part. I'll get to you in a second, Grant. Oh, it's an F, isn't it? Okay, Grant, I understand what you're saying. What are you trying to eliminate? You're going after G first.
Well, get rid of it, and that would.
You could also do M with you and Curtis.
I want you to, there's nothing wrong with where you're going, Grant. Of course, it's G. That's probably why you like it, G for Grant. But you got to eliminate it twice. Think more than one step ahead.
Yeah, it'd be harder dealing with that.
That's the deal. You got to do it twice, right? You got to think 2 steps ahead, not 1 step, 2 steps.
You could multiply D by 4.
I understand. It's doable. It's very doable. I'm not disagreeing with you. If you want, we'll go that route.
No, we don't have to make it.
I think the easiest thing to do is to either attack F or M. I'm going to attack M.
I can come up with M pretty quick. Multiply the top by 2, add first and second, or subtract, and then I can do the same with the second and third. So personally, I'm going to actually attack
You just do you and Curtis. Right, have a good time. You're bringing the same M.
well, yeah.
Then all you have to do is subtract it.
So we're looking at those. I just copied down those 2 equations. If you're looking up the board and not sure what I wrote, I just copied down the same 2 equations.
Yeah.
I heard subtraction. I agree with that 100%. M minus M is what? What's a half take away 2?
-3.
Let's do decimals. We wrote the problem using decimals. We'll stick with decimals, and they're nice decimals. They really are. They're not rounded numbers. So we just stick with decimals. What's 1 minus a half?
Would be a half.
3 1/2. 8 minus 9. -1. So there's an equation with 2 variables. Now you got to do the same technique. You got to eliminate M at the end. You do it one more time. Pick a pair. It can be 1 and 2, or it could be 2 and 3, but you can't use 1 and 3 again. 1 and 2? Well, we want to eliminate M. I understand you can get away with G. We got to eliminate the same thing twice. Has to be done twice before you ever worry about another letter of the alphabet, kids. Pick a letter, get rid of it. Twice. What y'all saying, 1 and 2? What is happening top for you?
Multiply by 2.
Multiply by 2. I'm going to do a -2. Because I like addition. negative 2m minus a g minus a 2f equals a negative 16. If you don't understand the negative 2, you can just pause it. 2m plus a 0.5g plus 0.5f is 9. Didn't do any change to the second equation. It's written as is. And again, the reason I multiplied the top by negative 2 is so that I could use addition instead of subtraction, because you are more likely to make a mistake subtracting than you are adding. You are. Those can be added together. Negative 2 plus 2 is what? Negative 1 plus a half?
Negative 0.5.
Negative 0.5 g. Negative 2 plus 1 plus 0.5. I got plus minus. Minus 1.5 f and negative 16 plus 9. Negative 7.
Oh, that's all. Okay.
That was just adding and subtracting things. Oh man, we ran out of time, didn't we? Well, I'll save that for y'all tomorrow. You can start on your homework. No, let's not do tomorrow, son. You can finish lesson.
But you can start on it. Or you can just, postpone it and forget anything. This was what, second period?